Yeah, I'm trying to bind. I'm trying to bind just everywhere, right? Let's call this hand.
Distinction.
Distinction. Yeah, so I'm trying to bind just everywhere, man.
I'm trying to bind everywhere. I'm trying to bind everywhere.
Everywhere.
Trying to bind
Exactly.
everywhere.
Thanks. Hello, how you doing, man? So we have a question here of the current. Okay. The current in the wire varies with time. Oh, so this current kind of is time increase, maybe the current increase, or the flow of the current increase or decrease, etc. So, and then they give you the function here, IT equal to. So this is time is in second, just like I would say whereby T is time in second. How many coulombs? Oh, so what is coulomb? Coulomb is the unit of quantity of charge. So we want to know which is going to pass cross section of the wire in a time period between 1, 2, 3. Oh, this is very easy question. So what I'm going to do first and foremost, I'm going to write my information. What is my information? All of this information. My time I got, my current, my current, which is in time, equal to 6.0 plus 4.8 time. Oh, so this is a current given. And what do they want here? They mention something here, if you look careful. They say time start from 0 to 3. Okay, so they say look at this. That's where you get the concept. Current in a wire varies with time. Oh, current varies with time, but we know for fact quantity of charger. You see what I'm saying? So now we know for fact. Okay, so we know for fact current. We know for fact current equal to change in charger over change in time. Okay, point of charger change in time. So remember, I want to get charger. What I'm going to do, I'm going to make subjects that charger quickly. Okay, so let's make that charger subject, the subject, the formula. So now we're going to say, oh, so this is going to be charger equal to current times changing TDT. But the current is given, which is, so we're going to replace this with that. Okay, so now we're going to say here d theta equal to current we have, which equal to 6, and then we plug what 4.8 what T, and then bracket. You see this one? We replace or we insert that value and then T. So the next thing here, we're gonna integrate throughout. You know what I'm saying? So let's integrate. Okay, because if you have a dt, you want to get the quantity, and then you want to get this quantity, you have to integrate. You know what I'm saying? So let's integrate. So when you integrate here, you're going to integrate on the left, and then you're going to integrate on the right. Okay, but remember, they say that the time start from 0 to 3. So here, when you integrate d theta, you get theta. This is the integral rule. You know what I'm saying? You get theta, and then here we can separate. So we're going to say integral. But our time, remember, here you write time start from 0 to time equal to 3. So let's separate. So I'm going to write for the first group, which is 6, and then dt plus. Now I'm going to say this integral, okay? The integral, okay, start from 0 to 3 also. 0 to 3, you can say t equal to 0 to t equal to 3, but it's 4.8, so say 4.8 of t. It's just t there, you see t? dt. In other way here, you separate, you say integral of the first group plus integral, like this neck gotta come in here, okay? So we know, okay, this is theta equal to constant number in integral, you can take it back. So this is going to be integral, and then this is going to be t, start from 0 to 3t, and then we left with only dt. With plus, we do the same thing here, 4.8 must go to the back, and then integral t 0, and then t equal to 3. So here you're going to be left with t, what, d? dt. You know what I'm saying? So now you say here, easy man, let's go. Okay, so what we're going to do now, so remember we have a rule of integration. Whenever integral, let me write here. If you integrate, let's say dx, this is equal to just x. So if we integrate, let's say integral of dt, what I'm going to get, you just get t. Okay, that's a integration rule. But so this is when you integrate, 6 is just a 6, so theta equal to 6 is just a 6. When you integrate dt, you get what? You get t. And then we have a plus, we're going to write here plus, and then after that we got 4.8, and then 4.8. Now this is a different case because you integrate t dt. So this is power 1, this is the power of rule, the power of integral. So what you do is see, means, when you say t means t power 1. So when you integrate, you see that t? So you're going to write your t. You see this number here? Always add by 1. So it's going to give us 2. And the same number which you got, which is 2, divided by the same number, which is 2. Okay? And then we're going to say all of them, we have to write our limit, starting point and finish point. 0 to 3. So I'm going to say 0 to 3. Okay, the question now is finished. So what we're going to do now, we have to say upper limit minus lower limit. What is the upper limit? Our upper limit means this maximum time and how far the current flow. So we're going to take these 3, because remember these are t, 3, 0, t. So we're going to substitute everywhere where there's a t here. Look, I'm going to do this. Minus means you take. So our theta equal. Okay, upper limit minus lower limit. What is the upper limit? Our upper limit equal to 3. So we're going to take everywhere there's a t, we plug in 3. So this is going to be 6 bracket. See here, it's going to be 3 plus 4.8. And there's a what? 3 square over our 2. Minus, you see this group? Minus lower limit. So lower limit means whenever there's a position of t, now we put the lower limit, which equal to 0. So it's going to be 6 times 0 plus 4.8, 4.8, 0 square, and then we over 2. So take that one, plug in the calculator. After you plug in the calculator, it's going to give you 39, okay? So this is going to be 39.0 coulomb. Oh, so from all this information here, from this question here, according to how they ask, how many coulombs, okay? If the current is going to be flowing from 0 to 3 is 39 coulombs. That's how you do it, man. It just wastes your time. How you do this question? It is easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If it's make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time, you know. Subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can, okay? It's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects, you know. Thanks a lot, man. I appreciate and I love you. Peace, man. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Coulomb. I go to South Primary School.
Yeah, China with Bantu.
China with Bantu.
China with Bantu is everywhere, right? So this is my other student. His name, what's your name?
Matthew.
Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise, I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Bantu is everywhere, man.
China Bantu. Everywhere. China Bantu everywhere.
Everywhere.
China Bantu.
Exactly. Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Abungazi Sing with me and say,